So share screen and lesson 1 pets. Share. Okay, so you guys should all see the lesson 1 bits Jupyter notebook. And what that was doing, if we whiz through it fairly quickly, I'll establish a new session. And just so everybody remembers, so I'll give this a wee refresh. The change runtime type, if you're using Collaboratory, is hugely important. And you need to make sure that the hardware accelerator is marked as GPU. That we save. And we will just run the first cell.
Just a wee question, Finley. Are we recording this? Just because it might be useful later.
Yeah, I've clicked record on this one because someone requested it. That's actually a point. If anyone is objecting to this getting recorded, can they let me know now, and I won't record it. I'll take that as no objections. Okay, so the this is a rehash of last week. So what I'm showing you is lesson 1 pets. This is taken from the MOOC that the Fast.ai organization offer. It's an exceptionally good MOOC, and I would recommend everybody do it. But what I'll be doing is whizzing through a high level what they're covering. So it should be a starter for 10 if you go and do that. If not, then it's going to be enough to get you going, even if you don't do the MOOC. So the example that they use in the first lesson is a classifier. So that's where you're taking an image input and converting it into a label. So your simplistic one would be a cat versus dog. But this one is actually a wee bit, oh, Alistair Cooper, you've raised your hand.
No, sorry, I just had to lower my hand, and it seems to have gone raised it for some reason. On my hand, it was lower because I noticed it was already raised.
All right.
I don't know why it's done that. It's showing it raised now.
Good at this. Okay, so the what was the right? So I lost my train of thought there. The approach that we're doing is transfer learning, and the class of problem we're solving is classification. So we're taking an input image and converting it into a label. The label in this case is going to be a variety of cat and dog breeds. So we're just going to whiz through it. The first section here is loading the vision libraries, which are the ones that look after computer vision, and the metrics one, which is a way of reporting how the model is performing during training. Next thing we select is batch size. If you've got a decent GPU, 64 works fine. If you're running on a very low end GPU, you might need to reduce it. I would normally drop it by half in the first iteration. And the reason you'll know your GPU is not up to it is you'll get out of memory errors when you're running your training. So if that's the case, half it. If that doesn't work, half it again. And if you have to half it again, then just get a better GPU. So this is showing you the help options. So you can type in help and then the function name, and it will give you some information. You can also put question mark in front of the function name, or question mark in front of the function name, and it will actually bring you to the source code. The Fast.ai community encourages everyone to look at and understand the source code and contribute to the documentation if you find it not good enough. So what this is doing as well is it's got some really good example data sets for you to use when you're learning. Untar data, what it does is it pulls the data down and then also expands it for you. So passes back the path that it expanded it to. So you can see here it's dumped it into root.fast.ai/data/Oxford II hit, and then it's got images and annotation directories. So we then just create a path to hold both of those. So you have the path/annotations and path/images. And then we use that to get some file names out. And you can see here now that it's the label's actually part of the image file name. So if you take the section before the number, and that constitutes the label. We then randomize the seed. That allows us to, that basically sets you up. So you've got a nice random, but importantly, because you're giving it a static number, a repeatable process, so it's pseudo-random, and we're also defining what the path is using a regular expression. So what that's doing is exactly as I was saying, it's telling it to take the first part of the file name just before the number. Regular expressions are, yeah, they're signs in terms of cells. So the next bit is the data bunch object. So what that's doing is it's taking a bunch of data for processing, and for each of the data types, there's a specific data type class. Sorry, data bunch class. So for images, you use the image data bunch. There's a lot to unpack in this line here, but what it's doing is providing a data that has been processed sufficiently for training to go ahead. As you can see, they're calling the function from name RE, so that's telling it to use a regular expression. You pass it the path, the file names, the give it some default transformations. Transformations are basically the augmentation of data. So it's taking the image and bending it, stretching it, downsampling, resampling it, messing with the color balances and things like that. And what it's trying to do is fool the model that you're training into thinking that there's substantially more data than there actually is. It also helps with overfitting, which is where your model becomes fragile and can only detect your training data set. The size that you're providing it with is the size of the image that you want it to crop to, and the BS is the batch size that we set above, and then the final thing, dot normalize. What that's doing is it's normalizing all your input data around a mean of 0, and I think it's usually plus or minus 1. So what it's doing is it's taking all your really, really high values and pushing them into a normal bell curve. The statistics that you should be using are the statistics that the initial model was trained on. So we are going to be using ResNet, and ResNet was trained on the ImageNet dataset, which is a large public dataset that holds millions of images of things like cats, dogs, airplanes, keyboards, and notepads, and things like that. So this bit takes a little while. I should have clicked it while I was talking, and oh, actually it was quite quick. And then you've got some really good helper functions like show batch. So what this does is it takes the data and takes a chunk of the data and shows it to you. So you can see lots of pretty pictures of animals. Oh, sorry, I've jumped off of there. Enter. So this next bit is listing all the classes of data. So this is all the different labels that they are in the data set. The great thing about this is that you didn't actually have to hand code this. It detected it by examining the data that you provided it, which is kind of cool. The next bit is learners. So the learner is a class that handles all the training of a model. So this learner, what we're telling it to do, it's a CNN learner, which is a convolutional neural network. They're really good at doing classification of images, so that's why we're using it. And we're passing it the data that we have prepared. So that's our data bunch, so all the pictures of cats and dogs with their labels. And we're telling it to use an existing model, ResNet 34, which is a big convolutional neural network. It's got 34 layers in it, and it's not the best at the moment, but it's certainly one of the best. And we're passing it our metrics, so it's telling it to use that error rate as the reporting metric. So again, that does nothing other than treat that as a preference. That's how we want to see it report to us. So you can see it's now downloading the model from the internet for us. And then you can have a look at the model and you can verify, yeah, it's got all those wonderful 34 layers and it's full of lots of cleverness, but you don't have to. And then this is the bit, this is where all the magic happens. You're running a thing called Fit1 cycle. I went into that in a bit more detail in my last presentation, and what it's doing is showing you the ability to train at an aggressive rate at the beginning of your training, and then it slowly anneals that and brings it down to a smaller learning rate. So what we'll do is I'll stop at this stage, because that's basically that's like a 5-minute, 7-minute sort of run through what I did last week. And then what we're hoping we would do is start applying this to a different data set. So while that's training away, has anyone got any ideas for data sets that we could use? Because if not, I'm just going to use one that I prepared earlier.
Sure, not coronavirus.
Oh, everybody's doing coronavirus.
No, I said not coronavirus, whatever.
And there's one like Food 101. So like you have 101 categories of food items. You can images of food items.
Yeah, that would work.
Yeah. It's not like really big, but it's not also small. So you can.
Yeah, that's not a bad idea, considering everybody's had to do lots of cooking and stuff from home now.
You can have a guess at what you've made.
Well, what are you going to buy?
All right. Okay, let's see if we can find one. So let's go. Data set, and it's food. Is it Food 101?
Yeah.
Let's see if we can pull it down. Oh, it's a TensorFlow data set.
There's a Kaggle one as well.
Oh, there's Kaggle. Yeah. Oof, it's not as small.
There's a lot of food.
Yeah, do they have a light version of this?
5 gig, that's pretty big.
Yeah. It's going to be a bit much for a collaboratory.
Yeah, maybe we need to look for things which are maybe within a less than a gig.
I think there's one more called UEC Food 100. That shouldn't. Yeah, that's just 1 GB, not 5 GB. Less than 1 GB. UEC Food 100. Like U as in letter. Yeah. 100. Yeah.
There we go. All right, yeah, so people have been doing YOLO with it. Yes, it's just 1 GB. That should fit. I'm just seeing what the data looks like. Director names correspond to the food ID. And then you've got the food photos. And then you've got the bounding box. You probably don't need the bounding box information. So, link address. Ooh. Doing some live programming here. This will be exciting. It's probably not going to work. For the people that haven't seen this before, you can see the error rate after a single epoch of training, which only took a minute and 31 seconds. It's got the error rate down to just 10%. I'll spoil it for you. I think we get it down to about 6% error rate if we continue on with the training. Right. So what if we ignore all of this and we scroll right down to the bottom? This is where a little bit of the additional magic comes. If you open up your other data formats, there shows you a whole bunch of different ways to pull in data. So you can see the first one that's showing you as a default one, like the MNIST. So that's the handwritten, very tiny handwritten characters. It shows you building a CNN there in about 22 seconds. It's pretty quick. So it's showing you here that you've got the from name RE, you've got the from name function, and from lists. All right, so we'll jump back up here. Okay, so are we going to do this as like mob programming then, and everybody's going to have a go at it, or because if we just watch me bash my way through it, it's probably not going to be a good learning experience. Is everyone up for that?
Sure.
Yep.
Yes.
Yeah.
One question on the, sorry.
Sorry, go ahead.
Yeah, I was going to say, the past model, you said that the model is fitted using optimized based on accuracy. Could you change the kind of the metrics? So like if you wanted to optimize based on, say, like a precision or a recall?
Yeah, I think so. If you come up here where it's used error rate, so you've got Fast.ai metrics. Metrics. Oh, I think it. What was it? Recall. Oh. Recall. Let's see which one. I don't know if this auto completes. Let's go. We should be able to go jump to the. Let's check the logs and the sort of. Oh, hold on. I'll set this up its own one. Question. Let's see if this works. Well, object metrics not found. Oh, it's not. This isn't something I've done before. So, oh, that's no good. Let's see, error. Okay. See if that jumps us to the appropriate one. Okay, there you go. So signature error rate. It's torch tensor. Rank tensor accuracy. I'm sorry, I'm not 100% sure how we grab another one. I was hoping I could just show you quickly with the I've got to admit, I don't bother using any of the other ones. So this would be the first time I'd had a look at it. All right, sorry about that, Mark. We'll maybe let's put that on Slack and we'll see if we can figure it out together.
Cool.
Oh, sorry about that. I did think that would have been quite an easy one to do. So
In documentation, it says straight up like you can download recall or precision.
yeah,
Like
I'm sure
from yeah, on the Fast.ai documentation. I can do it. I just tried it, and I could import from Fast.ai metrics, import recall with R in capital. Yeah, same, and go class
is that what I
recall.
was doing? Yeah, you can see there, class precision recall F beta R2 score. Yeah, so they're all there. The Fast AI docs, that's a good call, Vishal. That's definitely a good place to go to get it. Okay, so if we try to get, so I'm trying to think where would we get the, so if we change here, we'll probably want to start breaking it around the point where we pulled the data set down. Let's see if I've got one that I prepared earlier. Go away. This is annoying. The tabs at the top are unfortunately getting caught by the Zoom. Let's go to Collaboratory. So this is the one. This is the one I did to mash up the example into something else. So tied to my Google Drive. So that's just installing Kaggle. Oh, that's why. I'm sorry. Yeah, this example's got. This one's actually downloading it from a Kaggle competition. So that's no good. Oh. Yeah, I think this is going to turn into a bit of a car crash if we try to do something completely unique, because I don't know if I'm going to be smart enough to do this on the fly, and I don't know if we've got enough people that are going to want to type. So do we just go for another example, or let's go hands up? Does someone want to take control and do some typing? No.
Is the other option for us to tell you what to type?
Yeah, that would work.
That's how I've done mob programming in the past.
Yeah.
Okay, let's do that then.
Me too. Usually tell someone what to type.
Cool. Right, let's do that then. All right. So I'm going to assume that we would start by modifying the part where we're downloading the data. So if everyone's happy with that, let's go for it. And
yeah. First, we need to
shout
download
out
the
and
data.
I'll type.
Okay. So where is the data located? On your local disk or?
It's located at the end of this link.
So copy the link first, the complete link, so we can access it.
So something like
So
like wget or something.
Yeah.
Yeah, wget with dual cur or whatever. Yeah.
Let's see if that works.
Yeah,
Yeah, so that's it, pulling it down.
Okay, that's the easy part.
And then should we, while that's happening, let's write the code for unzipping it.
Yeah.
So that'll be gzip, won't it?
It's a zip, is it? Yes. So you can just use unzip. I think it doesn't take any arguments off the top of my head.
Cool, and it'll be downloading into the same present working directory, won't it?
Yeah,
So we can
yeah.
probably
Unless you, yeah, if that's yeah.
we can probably do dataset 100.zip. Oh, I'm just looking at the ETA.
14
1
minutes.
gigabyte's going to take us a while.
Now maybe maybe Zoom's hogging the bandwidth.
Or
it's a really large file. It's
nice.
nice.
If we could have
15 minutes for 1 gig.
It's
Maybe
it's not the bandwidth to fill his machine, it's the bandwidth allocated to the server. It's actually downloading to the Colab server.
Yeah, that's true actually, yeah.
Yeah, it's going to Google's machines, yeah.
I think it's more likely the fact that it's 1 gig and that they're not gonna, they're gonna have some restrictions.
Yeah, especially news time. Can we maybe look for a data set which is a lot smaller?
There is a really simple example
one. Sorry, Alistair.
There's a really simple example one on the course, and it's just types of bear. It's black bear.
Isn't that like similar? Isn't that too similar to dogs and cats?
Yeah, maybe it's actually, if anything, it's simpler because there's only just like those.
What about someone did tell me about something to do with fashion clothing on Kaggle, but I can't remember the name of it.
Oh, yeah, I've done that one, and it's that's a huge data set.
Okay, yeah. Well, my girlfriend told me about that, and she did a master's in machine learning, so probably that's why.
Are we definitely doing image based, or can we pivot? Yeah, I guess we are.
Image is pretty simple, I guess. Isn't
it?
I mean, there must be something which is under 500 meg.
We could do natural language generation based on some text-based data set. It depends how loose we are in terms of what we want to do.
I mean, I'm okay with the natural processing because it's supposed to be good at that as well.
Yeah, I would jump off from this though. The NLP examples, they would use a different lesson to jump off from.
Okay.
It'd be worth covering how that works. That's a good hour in itself because it's quite interesting how the NLP gets done. Yeah. So rather than watching this progress bar, do you want to spend a couple of minutes looking at something else while that downloads?
Yeah, sure. Maybe the next lesson. I don't know.
Yeah. Okay.
Yeah.
We'll see. Let's jump this into. So rather than this one.
Yeah, probably next time we should probably prepare better with the data sets.
Yeah, definitely agree. Well,
yeah, but that's my fault as well. I didn't actually think about it at all.
Well, that's why I was assuming. I've got to admit, because nobody had picked a data set, I thought you guys would be like, fine, no, let's look at the next presentation.
Yeah, exactly. Well, I'll make a note for that for next time.
Yeah, that's the thing is, I figure unless we've got the data set downloaded, we'll not try a mob program. Because I could have kicked that off 15-20 minutes before we started.
Yeah.
So let's see here. We've got this is one of the ones that I ran recently for my team at work. It's to do with collaborative filtering and tabular data. So kick off presentation. You can still see that full screen, can't you?
Yep.
Cool. All right, so we'll jump over what is Fast.ai because we've just covered that. And we'll jump over setting up Fast.ai because we've done that. Okay, so what is tabular data? So if you've done a budget in Excel, it's a good parallel to tabular data. Tabular data is ones with column and row structure. It's very similar to the concept of databases and table structures. They still have the concepts of continuous, discrete, and categorical data. So continuous data is things like salary, height, weight. So they've got a value that's constrained by the nature of the data, but it can flow anywhere in between. So you can have a £10,000 salary, but you can also have a £10,001 salary, or you can even have a 10,050p salary. Your height is, you're not going to have anyone that's 100 foot tall, but you can have pretty much any variation between something like a lower bound of 2 feet and I would say probably about 11 or 12 feet would probably be the maximum that anyone could be. So you've got other things called discrete values. So they're values like ages, numbers of customers. So if you're taking age just as only taking the year part, or only taking full numbers of customers, they are fundamentally different from continuous variables, but in Fast.ai Tabular, they're just treated and lumped the same. And then the one that is treated differently is categorical. So they are things like species, role, marital status. So you've got a predefined bucket of values. It's almost like a drop-down list kind of thing. So if you open up, so let's jump in, kick it off. So steal another server from I'll kill off this one. Need to give up one of my tabs. So we'll jump into Colab, we'll do file, open notebook, and we'll jump over to GitHub. Just stick in Fast.ai course fee free. That jumps you straight to the correct repo. And then, what was the one that I was going to use? Lesson 4 Tabular. Oh, sorry. Back to present, we'll jump to the next one. So that's just showing you how to launch one of the existing examples from GitHub. And this is one of the really cool things. I think that it provides us the ability to do the pre-processing of the data and do data quality checks on your data. So I don't know if you've looked at normal production data sets, but because a lot of the times, if you're like, say, working for a bank, the data is maybe being built up over 20 or 30 years, and the customers that we had 30 years ago, we didn't ask the same questions as we ask now. So you'll actually have a lot of the historic data that has null values in fields that will get populated for new customers. So you'll probably find that across an awful lot of data sets that there's missing fields. So the fill missing function, what that does is it populates them either with a range of values. So you can have it filling it with the mean or a flag that just says is missing. The extreme values in continuous variables really mess with predictive models. So if say for instance, you had 2 key inputs, so you had age and salary. Because the ages are only going to go up to like 100 and the salaries can go up to the millions or even billions if you're including people like Bezos, the very, very large numbers, they swamp things like neural networks. So the best thing to do is normalize them around a mean of 0 and a range of something like -1 to 1. And there's a normalized function that automatically does that for you. The categorical fields also need to be bucketed. So categorify is the keyword that does that for you. So it builds the list out of the data rather than you have to troll through the data and do things like run queries like select distinct blah from table. It does all that for you. And the other cool thing about it is it expects you to use a pandas data frame as input, and pandas data frames are super easy to use. Reading CSV is probably the easiest way to populate them if you've got CSV. So if we jump back to here, we've got our warning. It gives you this anytime you're running stuff that Google hasn't offered. So we'll kick off this. That one takes a little bit longer because it's actually building the virtual machine in the background. Tip here is Shift Enter, executes the cell and jumps to the next one. So it's a lot easier than clicking the play button. So this one's a bit dodgy sounding. It's adult samples. It's a list of adults. That's all it is. It's nothing worried to worry you.
Finley?
Yes?
When the it works out the bucketing for the categorical variables, does it take into account if the variables are ordered, such as low, medium, fast, low, medium, high, or anything?
It doesn't.
Or does it just put it in a particular bucket?
It puts it into a bucket and swaps it it swaps it basically for a numerical lookup. That number though doesn't have any. It doesn't infer anything. The model, when it trains, and it trains against whatever you're wanting it to predict. So that's your dependent variable. So you're not going to. When the model trains, it will find the distribution of your data set, and it will infer things like having good education correlates to high salaries, but it doesn't have any knowledge that having bachelor's degree is a better thing than a high school diploma.
Right, gotcha.
Does that make sense? Like, you're not programming in, you're not providing it with those hints. You can actually improve the way that the model works by giving it those kind of hints, but categorifying the input doesn't do that.
So it doesn't order the categorical variables. It just assumes it's like a green bucket, a blue bucket, a red bucket.
Yes. Yeah.
Rather than saying a small bucket, a medium-sized bucket, a huge bucket.
Yeah. So you can see here what this is doing is it's telling us what our dependent variable is. So the thing we're trying to predict here is salary. The categorical names, we're telling it the list of columns that contain the categorical information. And then we've got our continuous names, which are all our continuous and discrete values. So we've got age, single, good, whatever that is, and education number. So we run that. We've not actually done any work there. All we've done is define what the work will be, and then we build a tabular list from a data file. So what that's doing is it's passing it the categorical names, passing the continuous names, and then it's telling it to build a tabular list from the 800th to the 1000th. And then we can do the training on it. So that show batch, what it's doing is it's showing us the a small chunk of the data, the same way as we were showing all those pretty pictures of the cats and dogs. And then we establish a learner. So this is where we start getting back onto the similar approach as we did with the classifier. And we can run learn fit, and it does it incredibly quickly because it's not a lot of data. So in 6 seconds, you get something that has accuracy of 82%, which is pretty good. So again, that's when we're looking at how we define our metrics. So we've used accuracy there rather than error. And then we can run inference. We can grab a row and we can predict. And it's decided for row 0, it's incredibly unsure if the salary is over 50K. So that's, if we do, let's add a wee row in and we'll see what row is. We can just do that. So we can see what the row contains. So it's married civil spouse, it's a wife, a white female from the United States. And the salary for her is actually over 50K. Because we didn't supply it with that data, it couldn't infer based on the data very clearly what the outcome would be, whether our salary would be above or below it. So let's see if we can get someone who's a little bit more obvious. So we've got a person with a master's degree, 14 years of education, divorced, executive managerial. We'll predict, see if it's got more confident with this one. It's a little bit more confident. It's saying it's probably going to be over 50K. Let's see if we can get anyone that's obvious. So this is a high school graduate that's divorced, unmarried, Black, female. So given this is an American data set, unfortunately, demographics is pushing her into 90% chance that she's under 50K. So that's a bit of social science for you. That racism's real. Anyway, that was a bit sad. Okay, right. So let's see if our data set's downloaded. That was a quick whiz bang through building a tabular data model. Tabular data is incredibly easy to do, very, very quick, with lots and lots of helper functions, as you saw there. Okay, so should we try and unzip this? Oh, it's inflating.
Finley, going back to the tabular data, would you try and narrow down the features when you do your AI?
Oh, of course you could. The feature selection's it's a whole lesson into itself. You definitely don't want to use all your features, and there's a couple of reasons why you wouldn't want to necessarily use all your features. Some of your features could have implications into ethics. Like, say for instance, we were trying to use this data to predict whether or not we should give a loan out to someone. We probably would want to redact things like ethnicity, because we don't want our model learning to not give people of certain ethnic backgrounds loans and not others. We don't want it to say, for instance, take into account the sex of a person. I wouldn't want to build a loan calculator that gave loans more to men than women, that sort of thing. So there's reasons for removing them, and there's also reasons for one of the things that I got caught out by once is I built a perfect model, and it was the only reason it was perfect is because it had the dependent variable, the variable I was trying to predict, and it had an effective duplicate of it. It's a bit like if you had if you had age and you also had number of days alive. They're not the same number, but they're fundamentally the same thing. So yeah, you want to make sure that your dependent variables not being used in the training, and you want to make sure that the any of the ones that are surrogates for that dependent variable are removed. And you also probably want to remove things that would just genuinely never contribute, but that's just to improve performance.
What about those ones that are related to each other, not the dependent variable, but independent variables that are related to each other? You could get rid of one, for instance, if it looks almost like the other one. Does that affect the model?
Not to my understanding. The benefit from removing them is that you would be processing less data, but that's stretching beyond my level of expertise.
Right, because for normal like linear models, you would need to get rid of that linearity, because it would just create a bigger error. But I wasn't sure if that's the same effect in AI, if AI can compensate for that. Neural net.
I don't think this is actually. I don't think the tabular model is actually building a neural network for it. I think this one's based on embeddings. Yeah, because your layers here, 200, 100, that's your embedding matrix. So it's not even building anything as complicated as a neural network. But yeah, again, that's save the complexity when you really need it. Let's see. That done. It's still unzipping. Oh, let's do it. Yeah, that's not going to do us any good, is it?
It's just going to list.
That's listing the path from the previous example. All right, okay, I think we're back. We're cooking the gas with this. All right, so what do we do next? We probably want to have a normal LS to see what's in the directory.
Yeah. Should be what we just see above. Yeah. I think it's the third one, which is the folder. Yeah.
Yeah, the uke fold. So
yeah, so we want to CD into that, I guess, or reference it for.
Yeah, I think we will do. We probably want to create a path to the. So
definitely to the yeah. So.
Food. And let's try that. Oh, of course it. So it's running two shells there. Someone needs to change the fire alarm.
Oh, that's the bell ringing here.
Okay, so we've got what looks like 100 folders, and each of the folders, I would guess, holds our different categories.
Yeah, if you look above, it looks like that. So you've got 67, then you've got like a number for the JPEG.
Mm-hmm. Yeah, that should work. So if we so we've got ls food 100. Okay, so we probably want to put in our. And we probably don't need this one. We can probably bin it.
Okay.
Then we'll close the help. What have I done? I've zoomed it.
You zoomed it.
There we go. Pinch to zoom. Okay, so we now know what we've inspected our data, so we know what the structure of it is.
And now we need to analyze it or load it, I guess.
Yeah. Get image files. So we want to give the path to the images.
So, but then there's like a number for every single different category.
Yeah. I've got sneak and
you can put the.
Should we try putting the root in and see if it's smart enough to?
Yeah, try it.
I
mean, it's got a load of files in it, but it tells you about the categories. Maybe there's information inside the files. There's a category.txt.
Oh, I suppose for us, as long as it generates the.
Yeah, as long as
it picks the right ones.
Yeah, that's true.
Yeah, it's not finding any.
Go back up and have a look at the structure again. So it's got. Yeah. So it doesn't seem to be able to go into any of those.
Yeah. So should we refer to the documentation, because I bet you there's 100 examples.
Yeah, because it looks like there's a README in any case in the root of it. So if we maybe look at that.
So the README is going to be doing the. So yeah, so it's showing you here. You've got the directory names corresponding to the food ID, and the food photo files. So they are underneath it in JPEG files. So let's see, if we jump here and we do like Fast.ai load images from subdirectories.
Yeah, good idea.
Stack Overflow is a great way to do this.
Oh, I know. Oh, just ask Google. Down. Okay, what's
download images? All right. Okay. Does anyone got any guesses?
We can look at the API actually. I mean the Fast.ai API documentation. And because that's always the first point to look. So
yeah.
That might be a different method for subdirectories.
So if we click on vision.
Yeah, let's have a look. Images. Getting the data, yeah.
Getting the data.
So folder path.
If you've got labels as subfolders, then there we go. If you've got labels as subfolders, you can just say we can just say get from folder.
Okay, what was the one we called?
I think we were doing the slightly more complicated get image files.
Oh, okay. So let's give that a go and see what it spits out.
Because we were doing it from regular expression. So let's what we'll do is we'll bin this one. I think we're okay to bin that one. And then what we're going to do is something a little different here. So instead of from regular expression, we'll grab from folder. That sound reasonable?
Yeah, yeah. And we need to put the, maybe we could put the path in that variable so them to copy it every time.
Yeah, I think we can probably get rid of the first two of these variables that are getting passed. So that these first two parameters I don't think apply. I think we just give it the path. And the path, do we think we can just give it the, what was it, usic?
Yeah, if you can remember it. Or,
Yeah,
you can just put that value in a variable, reuse it.
Yeah, cool. We're just hacking this, so
yeah, that's true.
I think that's the only time we'll need it.
That's true. Yeah, so we've got the path, the trans. Yeah.
I think
what about the size? The size should be okay.
Do we know how big these images are?
No, but so let's. Can we just look at one sample image unless it says?
Let's see if there's any sample images.
Or just.
Or do we just roll with it and try for 244?
Yeah, I suppose worst case scenario it doesn't work. We just look at one of the images.
Yeah. Oh.
Oh, okay. Didn't like that. What does it not like? Something about your training set is empty. If this is by design.
It might not be liking this path.
Maybe you got to give it the absolute path. So the entire path from the root of the folder. So I think it printed it out at some point. If you go back up, or you can just like go into the folder here and do a PWD, and it should print the whole thing out.
Yeah.
I'm guessing here, by the way. I'm not. There's no like scientific reason, but.
Well, this is. I've got to admit, this is how I. This isn't too much different. I've managed to achieve anything in this.
Oh, that's great. There's content.
Slash content.
Oh yeah.
Does that look all right?
Possibly, yes. Not going to be any worse. Okay. Oh, this is the
index 0
part of the programming. User one, your training set is empty. Okay.
Well, let's get rid of everything else.
Simplify it, yeah.
Yeah, just try and load the file so we can actually, before we compile it. So try that again. And if that's 0, then we know it's not reading the file, okay. It'd be nice if it gave a nicer error. Okay, can't find it, but if you look down here, so data equals image dot from folder, that's where the error is, and then it says, oh, that's a comment. It actually says index error, which means it's not found anything.
Mm-hmm. Let's just make sure I've got something. Image data bunch from folder.
Because it should find a subfolder, as it said, right? So data equals, unless our structure, are we sure we've got numbers and then it's the actual JPEG underneath it?
I'm pretty sure.
Yeah, but it would look for an infinite amount of subfolders, I'm assuming. It doesn't have to be one, so yeah, they are there.
Should we try having a look? So was it?
If you do an ls, we should do, if you do a -LA, I'll give you all the details. It shouldn't make any difference. There's no hidden files, but.
Yeah, it shouldn't be. That's the current directory. So if we put the.
So yeah. So then if you add.
And then if we add one of those numbers to it.
Yeah, so just tick 6, which I can see here.
Yes, it's a whole bunch of JPEGs underneath the directories.
Yeah, unless they can't read it, because.
Shall we try one of them, like 6, for example?
Yeah.
So
yeah,
it might have issues going recursively.
Yeah, good idea. Take 570. That's a random one. So that was 6.
So yeah, we know that one's definitely got some in it. It's still giving the same error.
What we could do is, like, just to prove this can actually read a single JPEG, we could go back to the other function and actually put an exact file in. But then it should be reading this, unless it's a read error.
No, this I think what we're doing is we're probably passing the path incorrectly, because there is the concept of a path.
Yeah, it must be a path issue.
So we'll define a path.
Yeah, use the path in any case is probably as a variable makes it easier. Good idea.
Putting that in, although we want to get rid of the 6.
Yeah, so it should just be up to get rid of 6 and leave the slash maybe.
Yeah, we can do it. We can try that. So just something like that then?
Yes.
Give it a go.
Yeah.
I thought that was going to work.
No, I didn't. Well, someone said in the chat, from the docs from folder, so you should have a train and a valid folder. How do you define a valid folder?
It normally does the building of the validation data set without you forcing it to.
Yeah, I mean, it's only loading up the I see you mean, yeah.
So should we try and see if we can find an example for the...
Yeah, good idea.
So something like the from folder, wasn't it?
Yeah, from folder Fast.ai example. Because it'd be nice if we could actually load the file up.
Yeah.
Here, there's a...
Someone got the same error online and they solved it by using something else called image item list from folder, random split, so on. We can try that. I posted in the chat.
Yeah, I just saw that.
All right, cool.
Have a look at that.
So what am I typing in instead? So instead of from folder, it was from...
Hang on, I'm looking at it as well. So, according to this, okay, this is, oh hell, that's a heck of a workaround. So they did like a cast as well.
It might be that this is a red herring. As the person says lower down, it might also have to do with the path. So I think it's worth us just trying to load one image.
Yeah, that's what I was suggesting before, because...
Yeah, I think it would be a good thing to do the steps.
Yeah, if we could just try, if you remember the original function, which dealt with just images, maybe we could try and just go back to use an app, but just go to maybe one folder which is put images in, because that did work on that previous example that we've tried.
Cool.
If that makes any sense.
I'll see if I can grab the earlier example. Sorry, I'm clicking all over the place.
It'll be something very stupid. It always is.
That one. Pets. That one should have the original. That should be the original pets. This is the path annotation. So that was the this was the one where it was doing the data from a regular expression. Which I don't think is going to be. I don't think that's going to be what we're needing.
No.
I found another idea online. Someone saying that if you're in Google Colab, you shouldn't put in content. You should just put in the name of the folder. I don't know if we tried that already.
Can we try that straight away? Unless it's completely the leading slash at the end. So I suppose you could put the name of the folder, but I'm sure we tried that.
So
I think we should just try the folder name. That's what the suggestion from this person. I don't know, work for them.
So get rid of slash content.
Everything but the name. Yeah.
Oh, I see.
No.
Nope. It's a shame it's not more specific at the
what
error.
Does path do, by the way? Oh, sorry.
Oh yeah, is path an object that you can print out?
Yeah.
Mm-hmm.
Oh.
No. See, that's nothing in it. Oh, sorry.
Didn't print it.
Yeah, so
Okay.
it's turn it into the path of the type they like.
POSIX path. Oh.
Could try just giving it the path name as a value.
Let me try that.
No, same error.
Unless it's the app, because I noticed in the files are they read only? They're not read only, but that shouldn't make it.
The input
Shouldn't
doesn't
stop it
need
reading it. Yeah, it's not writing, so it's only reading the file. So
don't know. I'm just guessing here.
That's better.
That different error message.
Yeah. So what does it say? Or maybe it's just bad luck with this particular training set. It's just doesn't work.
I honestly don't think there'll be anything wrong with the data set.
No, you're right.
Have we mounted? We should have, right? Mounted the drive.
Oh, we've not mounted a drive because the data's just been downloaded into the ephemeral machine. It's on the VM directory.
Yeah, we just downloaded it like brutally onto the machine, right?
Mm-hmm.
So it must be something to do with the path. So we've tried PWD. It must be something to the function because the files are there. I mean, but what was the other function called from folder?
Yeah, from folder was meant to work.
Let's have a look what else it's got from folder.
Path or string, so it accepts it. Oh, do you think it maybe is that it needs to be? Yeah, so this one is saying that it needs to be in train, then valid, then test.
Apparently, you can say train equals, and say that this is train. If you do train equals.
Oh yeah, there you go.
Let me give you an example.
This bit here.
Yeah. Oh, I see. Yeah, maybe that's it. It's trying to do more than read it.
Mm-hmm. It's expecting that structure underneath.
Yeah.
Or other option is we could just make a structure like that.
Yeah.
Should we just make the structure like that and we'll just create a train folder?
Yeah.
So what would that be, like mkdir?
Yeah, minus. Well, you don't have to do minus p, just the name of the folder.
Yeah. So then
it'll be u.
It's like food train. What was it?
The structure. Yeah.
Lowercase train. And while we're at it, should we make their UEC.
Before it came up automatically.
Yeah, that was weird. And it was validation, wasn't it? The other one.
I think so.
Oh, valid.
No, valid and test.
And then we'll grab that again. And test.
Okay, so that should create this.
And then if we move so it'll be a case of moving. Oh, this is going to test my Unix. Hopefully there's some good Unixer on it that can tell us how
don't
to
worry.
copy the first 10.
So, oh, you want to copy the first 10?
Yeah,
so
I was thinking just take the first.
You could do an asterisk with a number. So what do the file names look like? So we can do a pattern.
They're just numbers. It's like 1, 2, 3, 4, 5. So we could like take 10 question mark, and it would take all the ones between 10 and 20.
Yeah, that should do. I mean, so you want to do CP.
Or do we want to just move all the directories into train and just see if it will train without a validation set?
Oh, because it's the directories that are going in.
Yeah.
Maybe just take 1 or 2 for now, because that's a lot. Or we could just, I mean, it'd be easier to copy them, but it's going to take a bit. Because it took 50, oh no, that was only the download. Yeah, okay, let's
we'll move them all into train. That's probably the best thing to do.
Good idea, yeah. Just do a C, so your CP, oh, you're going to move them. Okay, I'm with you now.
Yeah.
Yeah.
So if we move. /. So we need, so we'll move all the ones with 1 in front of them.
Yeah. Train.
Yeah, that looked like it'd do it.
Yeah, it should work.
So we'll get some data in there.
So,
should we see if we can build a data bunch now?
If we got everything right.
Yeah, that seemed to work.
Okay. Should copy them all.
I'm just thinking it's got to be numeric. We don't want to move our valid. Oh, to be honest, we could probably just move everything into it, except for train.
So, yeah.
That'll get us enough.
Yeah.
Because that should give us, if we do 3 and 4, that'll give us like 40 different classifications.
Yeah, that should be more than enough.
Prove the principle. This doesn't have to be pretty. It just has to sort of work.
That's a good lesson in data loading.
That's the thing is, it's even though it is automating it. So should we try and see a batch of the data and see if it doesn't look like bulldogs anymore?
Go for it.
There we go.
Nice.
Finally.
Yeah, I don't know.
Some really dodgy looking food there.
Yeah, there is. I don't know what 24s are.
It doesn't look if it's dead or alive.
Yeah.
Yeah.
All right, and then let's see if it's worked out the classes for us. Unfortunately, it's going to be boring. It's just going to be numbers.
Yeah.
There is if there is ways of prettifying this. You can build you can pass it the dictionary, but I figure we'll just roll on as we are at the moment. But be confident that there's better ways of doing this. Oh, should we see if we can train it as well?
Yeah.
So pull down ResNet 34 again. So what this will do is blow away our existing model. This next step doesn't matter. It's just showing us what the model looks like. And then, oh, should we try and fit it?
Yeah. So what was it last time? 10% or something error rate? I can't remember.
Yeah. And arguably, it's a harder task. Like identifying a hot dog or a hamburger, you'd think would be easier than identifying the difference between a long-haired and a short-haired Mediterranean.
That's true. There's so many different food types, I guess.
Yeah. I wouldn't describe that as a clean process, but it very closely approximated my first learning journey. And to be honest, anytime I do a new data set that doesn't look exactly like one I've already got an example for, that's pretty much what it looks like.
I suppose that's a challenge. Every data set does it how it wants. There's no like real standards. So
is it worth explaining how fit one cycle actually works while this is happening?
Yeah, that'd be good for me.
Let's see if I've got, I think I've got an example image of it already. Hold on, I'll minimize this. I don't like to, I mean, it is genuinely fast. Oh. There you go, use free at office.com. I promise you I'm not a cheapo. I actually have, I have 3 Office licenses, but damned if I'm going to buy a 4th one. Fit one cycle. Okay, you can see the slideshow here, can't you?
Yeah.
Okay, so I should be able to, yeah, so you can see here, this is the, when you're actually running the learner, there's lots of little things that you can run on it. And one of the options is learn recorder.plot.lr. And what that does is it shows you the learning rates that your model was applying. So when we're using learning rate, everyone understands that the learning rate is basically the multiplier that you apply to the back propagation when you're adjusting the weights and biases in your neural network. So when you work out the error for the batch that you have just processed, you'll get a numeric value that suggests which direction to push all the weights and biases. The learning rate is basically a multiplier, so it needs to be a very small one. Otherwise, unfortunately, what will happen is you'll adjust the weights far too heavily after each iteration, and you'll never achieve a good model. So you can see here the learning rate multipliers go between just above 0 to 0.02 at its most aggressive rate. So if, for instance, it said that you should move all your parameters 100 to the left, then what this would do is it would convert it into moving all the parameters 0.2 to the left, if that makes any sense. So what fit one cycle does is you can see here, there's numbers on the bottom are the batches. So for this to get through an epoch, there was about 1,000 batches of data that it processed. And when it started, it started off quite slow, and then it aggressively improved the learning rate to a larger value. And then once it got about a third to about half of the way through, then it starts lowering the learning rate back down to an endpoint. So what should happen at the end of each of your epochs, it will have gone into sort of fine tuning mode. And then at the very beginning of your next epoch, it will start messing it up a bit. But at the end of it, it should end up with another more fine-tuned, because it started off at a bit better state. Let's see if our training's finished. Oh, hey, there we go. spot the correct error. How are we going to generate a validation loss when we've given it no validation data?
Oh.
But
slight miscalculation.
We can quite happily appreciate that we have pulled a completely novel data set in with a bit of hook and crook. But obviously, if you're doing this yourself, you would spend that hour getting the data into the right state. And even if you did have to just manually copy random chunks or look up a really good do a little bit of Python train validation split functions. There's hundreds of different ways of munging up that data into the right structure. We know what the right structure is now, and we know that even with us doing really stupid things like not putting anything into the validation folder, it's still managing to train. This is pretty cool.
Yeah, pretty impressive.
So what do you want to do? Should we try and get it to do a prediction, or do we want to go back and try and get it to have some validation data? Do you think?
Would it be able to do a prediction without any validation?
Yeah, it will do. That would be effectively us doing the validation for it.
Oh.
Although one thing, because we didn't hive off any validation data, we would just be showing it one of the examples it trained on.
Maybe just give it a go, hope for the best.
Can do. So I think, if I remember correctly, it's something like learn.predict.
Yeah, let me see if I've made a note.
Shift. There we go. There you go. Learn.predict, or you can predict a whole batch. Let's see what it. So it's saying it was an item. Whether you want dropout in it. So should we just give it an item?
Yeah.
So take one from our data bunch.
Oh, I see.
Do we just do a batch size of one, or should we just pass it a batch so we can predict a batch of them at once?
Yeah, maybe that's a bit better.
Predict. Was it underscore batch?
Yeah, underscore batch, I believe. Or maybe not.
Hold on.
There it is. It was underscore. Yeah. No, it's pred batch.
Let's see what that takes.
DS type, whatever that is.
So we just give it our data, maybe? Yeah.
Because it's a dataset type.
And let's just run it. Why not? The one thing Fast.ai promises is sensible defaults. I'm sure if any of them. See what it's done. So it's given as a tensor.
What's a tensor?
A tensor's it's a list of a tensor is basically like an array.
Oh, okay.
So it's given as an array of values.
Like this data is just for one image. Like how many images are there in this variable data?
Can you do a count on it, or just or something like that to see?
Oh
what
yeah, we've probably just given it all of them.
Yeah, so it's producing the, I think, probabilities for each image for whole 100 images, like I don't know how many times for all images.
Should we try just giving it one of them?
Yeah.
I don't know if that'll
it.
work.
No.
Oh, it doesn't support indexing.
You're probably gonna have to see what the data structure's like.
Or do we have a? So we can get it. Or should we, rather than explore, should we just go and see an example of pred batch?
Oh yeah.
So just take that and we'll send ourselves out on an example hunt. There we go. Oh, or we could, why are we making this hard for ourselves? Why don't we use some of the easy example ones like that we saw before where we let Fast.ai do it for us?
Okay, how can we
We
do
roll
it?
down here and test the results. They've got things like functions like top losses. So should we do this little section here and copy it and run that instead?
Yeah, that looks more promising.
Yeah, so rather than code it ourselves, let's use one they prepared earlier. Give that a wee save. It's worth something. Oh, we can just keep rolling on the code, can't we? Losses index, top losses from learner. Oh, here we go again, because we've not created a validation data set.
I think not creating a validation is not really helping us.
Yeah. Well, rather than do we need to give it the validation data set, or can we just do it with the train data set?
We can try.
I know that's cheating. Oh, it just gives us a different error.
Or Finlay, sorry. So for that, I think when you got the tensor, it has probabilities for like each prediction for each image. You just do np.argument max, so it will give you the index for like for first image, which index, like which category it thought like this image is. So I think that's like halfway there. And if we do the prediction using NumPy argument max, just find the index where the probability is the maximum. So it will tell us which index
So
it
like
is.
a softmax.
Yeah. So where was that? Sorry. You got a tensor, right?
Mm-hmm.
When you're doing prediction.
Oh, did we get? I think we got rid of it.
Okay.
Well, we'll fire it back in. It was learn dot predict batch. That was it, wasn't it?
Yeah, that was it. That should give the tensor.
So should we pop that into, we'll pop that into a variable.
So I'm writing in the chat, something like that. So NP is from NumPy. So whatever we are getting the whole tensor, I think we can find out which index has the best probability. So we are just finding out which probability is the highest of all these values.
Let's see if I can get there's the chat. So I've got a different view from you guys because I've got the presenter window open. Chat. Oh, that's weird. I can't find it. Meetings. Glasgow AI meetings. Oh, sorry, Vishal. I can't see. I can't seem to see the chat.
The group chat.
Yeah.
I can dictate a bit. It's not like a big line.
No, it's only one line.
It's just one line. So just take these values in a variable, or
Yeah, so
just let x equals to whatever.
As
Yeah,
results
and then
equal. Plus code.
And then so like import numpy and then np dot argument max. Import numpy as np. And then np dot argument, so argmax. Yeah. And then just give result res. And then access one. I'm not sure. Will access? Oh, sorry, result comma access equals to 1, or just comma 1.
Like that.
Yeah. Work. Yeah. Yeah. So it is telling us like for all the predictions, what were the most possible for the batch you gave. What are the category?
So it's for almost everything's category 1, some 14s, 34.
Couple of 30. Yeah, there's a couple of 30s. 1, 2, 3, 8 30s.
So you gave 6. So batch was of 64 size. So I think these are 64 images, and for all those 64s, most of them were 1.
Yeah.
Well, we got some result eventually.
This is quite good fun. We're getting to, it's now, we've been doing this for like an hour and a half now. What's people's feelings? Do you want to continue on to for another 15, 20 minutes and see if we can do something more useful with it? Or maybe what would be a good fun thing to do is if we could continue on with this and through the week and see if we could get something, get this actually working. Because I think we've got what I would describe as maybe a start, like a faulty starter for 10 here. I could save this and share it out.
Yeah, that would be.
We could all have a wee hack at it and chat on the Slack. So if like people get, oh, here's a bit I managed to get working better, then we can.
Yeah, that sounds a good idea. Something to work on the weekend.
Yeah, and the other good, I mean, this is one of the things I love about Collaboratory is that if I save this and share it, like we can all collaboratively edit the same one.
Oh, that's good.
Yeah, let's do that.
Do we want that or to have different versions to compare? I don't know which one's better.
If I share it, then you can obviously branch.
Yeah, I mean, yeah, we can make our own versions then.
Yeah, make our own versions, and then we'll have like the Uber version in the middle that has all the best bits, like a Frankenstein version. And then I think that'd be good. We'd all feel like we contributed and had a bit of ownership of it, and we'd have a food predictor at the end. Maybe then, because what I thought, if we can manage that through this week, maybe for next week, I could show you guys how to put this up on the cloud as a inference machine.
Yeah, that would be good.
Mm-hmm.
I'd have to revise how to do it because I've not done one for several months, but I've been doing a lot of work on voice recognition because my aunt unfortunately got paralyzed, so I was building her a voice control thing to allow her to push buttons on a remote control.
I'm sorry to hear that, Finley. What are you using to make it? Because I've done some voice recognition in the past.
What I was using is you know, the TensorFlow Lite. They've got a neural accelerator board. It's like they call it Edge TPU. So I had an Edge TPU plugged into a Raspberry Pi, and it's taking the example code that they have. So what I've done is I've repurposed some of the keywords that their models already trained for, like move up, move down, go left, go right, move forward. So because those ones are perfectly fine for what I needed to do with it, I just plugged sort of smashed it into another example that I'd found of Bluetooth keyboard. So basically what it was doing is, instead of running the inference loop, when it went through each cycle of the inference loop, if it found a confident enough one that wasn't in the most recent DQ, it would then pass that as a command to the Bluetooth keyboard.
The keyboard, yeah.
So it's still a bit fiddly. I've got it working fine. It's usability things that I was running into, but unfortunately I can't get into the hospital to debug it now. I think I've got everything fixed. The only problem was if you leave, it was an Amazon Fire Stick that I was automating. It's got a default where it goes to sleep after 20 minutes, and when it goes to sleep, it drops all the paired Bluetooth devices. So
what's an Amazon Fire Stick?
Oh, it's like a TV stick. I've got one. You just plug it in, and you've got a smart TV.
Yeah. So you would need to turn off the auto sleep, or is that not feasible?
Yeah. I found a way of doing that. You can run the stick in debug mode, and you can actually change the timeout to like 1,000 years. But I need the stick. Oh, I found the chat. It's Alt-H. Yeah. All right. Well, I think that's probably the best thing to do. Well, I'll share this notebook to everyone. Let's see. Let's call it something else. Call
it food.
Yeah, lesson 1, food.
Not food.
I'm not really good at imagination on names, so I guess just put the word food in it.
Oh, sorry. I need to save a copy to my drive first. Or do we save it to GitHub?
Whatever's easiest. I mean,
yeah, Drive's probably easiest.
I mean, I've got GitHub, so whatever's.
And we'll call it food. Just make sure it's got all our fun stuff in it. Yeah, it does. And then share. And then get shareable link. Anyone can edit. Copy the link. Yeah, I think it's because I've got my screen sharing on. It's not letting me put the chat over the top of it. That is a weird feature, though. I'm sure I'm just doing this wrong. Where is the chat? I've got meetings. This is no good. Not, I'm so embarrassed. I should probably. I need to go on a Zoom training course. Is anyone really good at Zoom and you want to take the take the control next week?
I use Zoom every day, but not as a host.
Well, this is my experience of running it as a host. I do my work team meetings over this, like our social meetings, because we're all sitting isolated at home, so we don't have the.
So do we. I mean, our company's transferred everything to Zoom, which is working out quite well compared to Skype that we had before.
Cool. Well, what I can do is I'll email the link out via.
Well, you can post it on Slack channel as well, I guess.
Oh yeah, Slack's the best one.
Yeah, I've got Slack installed, so I've signed up.
Yeah, and that encourages you all to go on Slack. Cool. So if we go to the Fast.ai, so this is what it looks like. You guys can see, hopefully.
Yeah.
There's lots of really good stuff from previous things we did as well. So I'll paste it in here. That's the.
Great, got it.
That's the.
If I can find Slack.
What do we call? What is this thing called? Mob programming.
Yeah.
For a food classifier. Hey, that was cool. Right, I'm gonna. What I'll do is I'll stop recording. Hey, the Zoom chat's finally appeared. Finally. That's so weird. I clicked on that about 22 times, and then just that final click made it jump up. I wonder why it was hidden.
No, who knows?
I think it's just a glitch.
Yeah. All right, cool. Well, thanks everyone. Oh yeah, I can see it there. argmax ypred axis 1. Yep, that's perfect. Cool. All right. Well, what I'll do is I'll paste the recording of this into the chat. Thanks everyone who helped and contributed. I'm really chuffed that we sort of managed to get something functional. And you got to see a bit of tabular data as well. I need to show you collaborative filtering, NPL, and things like segmentation later on in the coming weeks. But my really whiz bang moment for this was putting a inference engine onto public facing cloud, where I could go on my mobile phone, go to a public facing URL, post a picture of like a freckle or something like that, and it would try and tell me if I had skin cancer. Like that, I was like, wow, that's a proper thing.
Yeah. That sounds really interesting.
So having our food classifier, hopefully over the course of the week, we'll get things like proper labels. So instead of 34, it'll be hamburger, and having something where you could snap a picture of your food on your phone and then test your own productionized classifier that's running on a freeware cloud thing, and seeing it actually tell you that what you're eating is a hamburger.
Making me hungry now.
Well, I'm too. I haven't had my dinner yet.
Me neither.
All right, cool. Well, let's I'm happy to leave the chat going if everyone else wants to stay on. But what I'll do is I'm going to drop off now, go get my dinner, and I'll stick another invite out for next week to do the next steps with it.
Yeah, great. I'm gonna go for my dinner as well. Thanks, everything.
Same. Thanks, Finley.
No
Yeah.
worries.
Bye, everyone.
Bye bye.
Thanks, Finley. Bye bye.